So today's lesson is on simplifying radical expressions. And a radical expression is just an expression that contains a radical, which is either a square root or a cubic root or some other root. But we just tend to deal with in the Algebra 1 curriculum just square roots. So the radical happens to be that symbol that you see, okay? The radicand is whatever number or possibly it's a variable under that radical sign. So we're going to talk about simplest form a lot, and we'll start with it now that we say that a radical expression's in simplest form when no perfect square factors other than 1 are under the symbol. You can never have fractions that are in, you can't have fractions that are under the radical, and you can't have radicals or square roots in the denominator of a fraction. So you can have a fraction as an answer, but you just can't have a square root in the bottom. Okay, so one of the biggest things that we're going to deal with is what's called this product property of square roots. And it basically says if you've got some number under a square root, you can break that number into two separate products. So you're multiplying a times b together. It's the same thing as just multiplying a radical by b radical. We use that a ton. One thing you've got to remember though is what are all the different perfect squares? And you should be able to count by perfect squares. So I'm going to stick a new page in here for a second. If we think about all the numbers that we count from, right? So we can count, we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to stop there at 10. But if we think about when we square all these numbers, anytime you square a number, the number that you get as the result is considered to be a perfect square. 1 times 1 is 1. 1's a perfect square. 2 times 2 is 4. 4 is a perfect square. And if we count by perfect squares, it goes 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. So bottom line, if you ever see one of these numbers under a radical, for example, if we saw the square root of 16, well, the square root of 16 is just 4, right? Because 4 times 4 is 16. So this is how we're going to also use this particular section, and you definitely want to have a chart like this that's available to you, and you can write all these numbers on your own, so you know which one of these numbers will divide evenly into whatever number you're dealing with, and that's how you're going to break down your perfect square or your number using the perfect square and this property that we just talked about over on this page. Let's actually make this make some sense. So if we take a look at our square root chart, and what I will do is up here, I'm going to write those numbers across. I've got 1, and then 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6, 7, 8, 9, 10. I want to figure out which of these perfect squares, the largest one, divides into 18. And the largest number that divides into 18 that's a perfect square is 9. So what I would do then with 18 is I would use that product property and I would say, well, the square root of 18 is the same as the square root of 9 times the square root of 2. Well, the square root of 9 is just a 3. The square root of 2 is irrational. It's not a perfect square. My final answer, simplifying radical 18, is 3 radical 2. Let's try the next one. Not rewriting that perfect square chart again, but you should have it by your side. The square root of 75 can break down into two other square roots. The largest number that divides into 75 that is a perfect square is 25. The other number that is divisible by 75 is 25 times 3. Well, 25 is a perfect square. Its square root is just 5. Root 3 is irrational. Nothing can come out of it. And there's your final answer. 3 times the square root of 24. Well, we want to break up the square root of 24 into two different radicals, one being a perfect square. The largest perfect square that divides into 24 is 4, and it's 4 times 6. Don't forget, this 3, it's multiplied by whatever comes out. Well, the square root of 4 is just 2, and that whole thing gets multiplied by the square root of 6. This answer, in simplified form, is 6 rad 6. Let's try another one. negative 2. Negative 2 has to be multiplied by two other radicals that multiply into 72. The biggest perfect square that goes into 72 is 36. 36 times 2. Negative 2 just comes down as is. The square root of 36 is just 6. And this square root of 2 is irrational. This final answer is negative 12 rad 2. I want to do this a different way because most people, when they think about 72, they think about 9 being the perfect square that goes into it. And I'm going to show you how you can use 9, but you'll have to keep going even further to get to the final simplified form. So if we take negative 2 root 72, we can make it negative 2 root 9 root 8. Negative 2 comes down. The square root of 9 is 3. Root 8 comes down. This becomes negative 6 root 8. But remember, you're not simplified completely until there are no more perfect squares in your radical. So then what happens is negative 6 radical 8 becomes negative 6 radical 4 radical 2. Negative 6 comes down. The square root of 4 is just 2. Radical 2. And lo and behold, you get the same answer as you did before. You have to. There's only one simplified form. It might take you less steps if you find the largest perfect square factor, or it'll take you more steps if you don't. We can do division just like we do multiplication. And division says, the quotient property, says if I take one big square root, that's a fraction, I can break it up into two square roots still as a fraction. And don't forget, you can never have square roots in the denominator, or one big fraction like this. So what I would do for the first one is I'd say, okay, well, radical 4/9 is radical 4 over radical 9. Well, the square root of 4 is just 2. The square root of 9 is just 3. You're done. Your final answer is 2/3. Number 6. I would do radical 8 over radical 16. Well, what's nice is the square root of 16 is a perfect square. 4 just drops out. But the square root of 8 is the square root of 4 times the square root of 2. The square root of 4 is a perfect square. It's just 2. So you really have something that looks like this. 2 square root 2 over 4. But don't forget, 2 over 4 is just 1/2. Your final answer then becomes 1 radical 2 over 2. And no, the 1 is not necessary. If you just want to have radical 2 over 2, that's fine also. A couple more to go. Root 75 over root 25. What's nice again is the denominator is a perfect square. Its square root is just 5. Root 75 is the same thing as root 25 times 3. The square root of 25 is just 5. 5 over itself is just 1. This simplifies just into radical 3. I believe there's one more to go. Root 12 over root 36. Root 12 over root 36. The square root of 36 is just 6. Root 12 becomes root 4, root 3. The square root of 4 is just 2. And I know that 2 6s is the same thing as 1/3. That radical 3 can't go anywhere. Here's your final answer. Again, you don't need that 1. If you just want to put radical 3 over 3, that's fine too. There you go. Good luck.